How's it going, everyone? So in this video, I want to give you an overview of how you can write your first Solidity contract using the Truffle framework. And there's also a couple of other tools we're going to use as well to make the development process a lot easier. So let me just go ahead and show you what you need to have installed. If you want to follow along, I recommend that you install these along the way. So the first thing is MetaMask. Basically, this is a wallet that is set up in your Chrome browser as an extension. And once you have it installed, you can click up here and it's going to create a wallet for you, right? So a private key is going to be created for you, and you have the ability to add money to it, send money, etc. So you need to have this set up because we're going to be using this to connect to a local running Ethereum network. So I'll give you a quick little overview. Basically, when you have it set up, you can click here and you have a list of networks, right? So on your networks panel, you can add a new one, which we're going to do to kind of point it to a local tool called Ganache, so that you can basically write contracts to a local running network. Also, you can go here, you can kind of add and import new accounts like so, and we're going to do that in this tutorial. So let's also check out the Truffle suite. So this is a Ganache here. This is a UI that you can use to basically run Ethereum locally, and you can kind of deploy contracts to it and look at transactions and all this stuff. So you need to have this installed so we actually know what we're doing. We can actually inspect like the blockchain's data structure of the contract and whatever. So make sure you install this one. And then finally, the last tool you need to install is something called Truffle. This is a development framework for kind of writing these Solidity contracts. So do an npm install g truffle, and that should set it up. And we can use that to basically spin up a project that will allow us to write these smart contracts. So let's just go over to VS Code, and I'm going to actually spin up a Truffle project. So I'm going to say Truffle init. And assuming you have Truffle installed, that's going to create a couple of folders for you. It's going to create a contracts folder, which is going to have a migrations.sol file. So if you don't have this highlighted correctly, make sure you go over here and install the extension for Solidity. But once you have that set up, it should be highlighted and you should be able to see that we have a Solidity contract kind of written here. This is used by Truffle, so don't really worry about this file. Use behind the scenes to keep track of what migrations you have deployed. So the second folder is migrations. This is where you're going to write a file to tell Truffle what contracts you want to deploy to the network. So this is really straightforward. You basically just import a contract and then you basically tell it to deploy. We're going to be using this for deploying our new contract that we're going to write. And then lastly, you have a test folder, which you can write your tests over your contract. This is really important to understand how to do, because really the only way to test that your contract's working is to get it deployed to a network, which can cost money or can, use up a little bit of time. But if you have all this stuff running locally, you can do test-driven development and actually deploy these contracts locally and verify they do what you expect them to do. And then lastly, there is a truffle.config file. So this is a file that tells Truffle like what network you want to point to and a bunch of other configuration. We don't have to worry too much about all of this, but what we do want to worry about is we are going to be running a Ethereum network locally, right? So we need to make sure we uncomment this part of it. And you may have to change the port depending on what Ganache spins up. But once we've saved this file, Truffle knows what network to connect to and what network to publish contracts to, etc. With that being said, let's actually spin up a Ganache, the Ganache UI that we have installed. So I'm using Mac. I can just do Ganache, and that is going to spin up that local Ethereum network like I talked about. I'm going to go ahead and click New Workspace here, and I believe I can point this workspace to this project that we just set up with Truffle. All right, so over here, I'm just going to say like tickets, because this is the actual like smart contract we're going to try to write. And I'm going to click Add Project, and I'm going to point it to that tickets Truffle config here. So let's go ahead and open that file, and I'm going to say Save Workspace. That should restart Truffle, and we should get a list of a bunch of accounts that are associated with this network now. So I recommend you play through this and kind of get a good understanding of how it all works. So basically, when you spin this up, you get 10 accounts with 100 Ethereum each. So that should be enough funds to kind of play around with. You have the public address here, and you also have the private key. So if I look at show keys, you will see that the private key will show up for this address, and we will be using this in our MetaMask wallet. So I'm going to go ahead and copy this key right now. We're going to use that in a bit, but let me continue sharing with you how some of this works. So we have your transactions to kind of see what has happened on the blockchain. Nothing's showing up right now. We have contracts to see what contracts have been deployed, and we actually dive into those contracts to get more information about what the blockchain state represents for that contract. There's also events and logs. Most of these are just blank now because we haven't actually done anything. So let's go back and continue to set up Truffle so that we can actually use this network. So I'm going to go ahead and copy this port here. and go back to my Truffle config and just paste that in, this will tell Truffle that it knows to connect to this Ganache local running Ethereum network. So at this point, if everything is set up, what I would recommend doing is say Truffle Migrate. And if this all works, it's going to basically take the first account in your Truffle, or sorry, your first account here that's defined in Ganache, and it's going to use some Ethereum for gas to deploy your smart contract. So we're going to see this maybe drop down a little bit, and then we should see some transactions happen and some contracts pop up for us. Now, again, this is just by default. It's going to grab index 0 of your address. You see how it dropped down by 0.01 Ethereum. If we go back to the terminal, we can see that it actually is deploying the smart contract called migrations. And we have a contract address. It tells you like how much gas it used, etc. And you can kind of configure Truffle to make it more realistic and actually like increase the gas price if you wanted to match the real network. But I would just keep it like this so you cannot use up all your Ethereum real quick. So going back over to Ganache, let's look at blocks. We see that a couple of blocks were written, and you can actually look at these blocks and see the transactions associated with that if you wanted to dive into those details. It might be a little low level for this tutorial, but you can see the transactions. It tells you what address sent money. So if I click on this one, it says that the sender of EDD sent some gas to a contract address. Okay, so this is like when we're deploying that migrations contract. And it tells you like what method was called on that contract. So this is really useful for debugging to make sure that stuff is actually being invoked, and you can inspect how much gas is used and stuff like that. We can actually go over to the contracts here, and you see that we have a migrations contract deployed now. So if we click on this, we can view the address. We can see how much Ethereum is actually on this contract. Remember, you can actually have these contracts hold onto money, right? These smart contracts are kind of like a holding place for money, and then they distribute that money later on based on criteria of the contract or logic that we're going to write in this tutorial. But the main important part is you can actually look at the blockchain, like the latest version of the blockchain data here, and see what it's set. So we can see that this has an owner of this address, which happens to be the first account that we have here. I think it's called EDD. And then we can see that it actually upgraded an integer, or updated an integer to 1 after this contract ran. So again, this is only used for Truffle. Don't really worry about this. We're going to have another contract pop up here when we actually start writing our smart contract. And then you can also look at events and logs if you want to, but I think for the most part, we're going to focus on this contracts tab and the accounts tab. So let's continue setting up our environment so we can actually do something with all of this. So the next thing we want to do is go into MetaMask, because if you are new, you probably don't have MetaMask configured to point to this local network. So click on this MetaMask icon and click on this drop down here. You can click add network. That should open up a new page so that you can kind of configure your MetaMask plugin. And then you can actually start typing in some information here. So the network name, you could type in like localhost or something. You can enter in that URL that we got from Truffle. And then the chain ID, I believe, is 1337. I already have one set up, so you can't really see. But the other two are optional. You don't have to put those in. You click save. But now by doing so, you can actually tell your wallet to connect to a different network. So I'm not actually going to save this, but let me make sure I go back and you can maybe view that this is the correct chain ID. I believe 1337 is the default. So if I click on localhost over here, we got localhost, and then we got the address, and we got 1337. So I think you can set this up and you should be able to get everything going. Well, let's go ahead and close this tab. And I want to show you to make sure that you're actually selected on that network. Let's just go ahead and click on this drop down and click on your network now. So that's going to switch over your account over to a different network. So you might see your funds change. But I'm not going to use this account because this is my actual like real address. What I'm going to do instead is go to Ganache, and I'm going to go ahead and grab just any of these other accounts other than the main owner. So let's just grab the second one. I'm going to click on this show icon or the show keys and grab this private key here. So if I go and grab that private key, I should be able to import it. If I click on this little circle here and say import account, I should be able to paste that private key in. And now you see that I have an account with 100 Ethereum here. So this is what we're going to be using. And later on, if you don't want this account, you can go ahead and just delete it. You can go to these 3 dots and say remove account. But now we've told MetaMask to use this account for every future transaction. We might actually get around to using MetaMask at all in this part of the tutorial. This might be a multi-part tutorial because MetaMask is mainly used for like building out Web3 UIs, but I think it's good to understand like how it works. So I kind of want to show you that here in this tutorial, but I think that's probably the most we're going to be doing with that for right now. All right, so the next step, we actually could start writing a smart contract ourselves. So for this series, I wanted to keep it really simple just because this is our first smart contract. So basically I wanted to build like a ticketing system where I could basically say, I want a contract to be published that has 10 tickets and people can buy these tickets for a certain amount of money. And once they bought the ticket, it's theirs forever, right? There's no way to sell it again. It's just theirs. And then when the event starts, they can come and show proof that they own the ticket. So let's try to do that. Hopefully it's not going to be too hard. I wanted to start with something really simple. So the first thing I want to do is I want to go to contracts, and I'm going to go ahead and make a new one called like tickets.sol. So this will spin up a new file where we can start writing some Solidity contracts. And the first thing you want to do is start off with the pragma, which basically tells Solidity like what version you want to use. I'm just going to copy the one that we have in the migrations. There's probably some better way that you can do this. Again, I'm still learning about writing smart contracts in Solidity myself. So if there's anything I do in this tutorial that you're like, dude, this is totally wrong, call me out, leave a comment below. Okay, so we want to make a contract, right? So the first thing you can do is with the keyboard, you can say contract, and then I can type in like tickets. And the syntax for Solidity takes some time to understand, but it's kind of similar to like, I would say Java or JavaScript mixed together. I don't know, it's kind of strange, but make sure I spell contract correctly. All right, so we got a contract called tickets. And now inside this contract, we can actually define some properties, right? We can define members. Anything that you declare inside the contract is going to be deployed to the blockchain and stored there as data. So one thing we probably want to keep track of is who is the person who created this smart contract. So I'm going to say address. I'm going to say public owner is equal to message.sender. So when this smart contract is deployed, it's going to basically set the address. Again, this is like the wallet address. Going back to this would be this public address here, EDD. It's going to set that address and store it in the blockchain as an owner property or variable or whatever we're going to call it. So later on, anyone can actually view and see who owns this contract. And secondly, I can use my private key to maybe do something with this contract, like spend the money that was sent to it. So the next thing I want to do is you can actually declare constants outside of this contract. So I'm going to go ahead and say uint 256. I'm going to say constant total tickets. And I'm going to say 10. We just want 10 tickets. You can kind of make this whatever you want. Again, this is like a beginner's tutorial, so this contract we're writing is going to be very like static. I would recommend you spending more time to make sure that the contract you write can be like extended so that in case you wanted more tickets, you could easily do that. Because once this contract gets deployed, it's stuck there forever. It's immutable. So you need to make sure your code is written correctly and everything works. So what we're going to do is you can actually create something called structs in Solidity, and we're going to create one called ticket. And I'm going to use Copilot to let me just scaffold that out. So basically a ticket is going to have an ID, which means that like, is it ticket 0 through 9? We're going to use like zero-based indexing to kind of ID these tickets. And then we're also going to have a Boolean called is sold. Actually, I'm going to change that. I'm going to say uint 256 and I'm going to say price. So what we're going to do is if the price is 0, that means the ticket has been sold and the money has been moved to my owner's address. So the way we're going to do this ticket is basically it has an ID and it also has a price. The price is going to be starting off with something like static. So let's say someone needs to pay like 0.02 Ethereum to buy this ticket. And then once they buy it, I'm just going to go ahead and put the price down to 0 to know that we can't buy it anymore. So that's just the convention I'm going to use. There's probably different ways you can do this. But once you've done this, I'm going to declare an array. So I can do ticket and I can say I want it to be an array of total tickets of length. So this should be 10 tickets. And then I want it to be public, and I'm going to say tickets. So this is going to create a public accessible array that's on the blockchain that people can actually fetch and read. And we can actually initialize that later using a constructor. So I'm going to say constructor, and I'm going to call that. And inside this constructor, we basically just want to loop through all of our tickets. I'll just go ahead and let GitHub Copilot kind of scaffold that out. And we want to start off with, let's just make this cost like that much in Ethereum, right? So Ethereum is 1 to the 18th. I'm going to make it 1 lower. So I believe this will be like 0.1 Ether. So we're going to do that, and hopefully that should set it all up. So now every ticket has an ID and a price. And technically, we don't even need to keep track of the ID here because the index is going to be the ID. So I'm just actually going to remove this. We'll keep it simple. So what the constructor do is when the contract is actually deployed, it's going to run this code once and only once and set up this tickets array. Okay, so this might cost a lot of extra gas money because we're doing a loop over a static array, but it's going to initialize all these tickets so that people know that they can buy them or not. One other thing I kind of forgot is we want to actually keep track of the owner. So on the ticket itself, let's put a owner on this, and we're going to set that equal to, we'll say like ticket's owner is equal to 0. So this is like not defined. We can just set it to this. And I believe you have to kind of wrap it like this if you wanted to use address. All right, so now at this point, we actually have all like the metadata set up so that people can actually go and potentially look at tickets and maybe buy them. So we want to write a function that people can actually buy the ticket. So I'm going to say function buy ticket, and it looks like Copilot is doing a lot of the work for us. Let's actually look at this and see what's happening here. So this is saying that the function will take in an integer, and it's going to be public and payable. Let's actually look at this. This is just a normal function, but it takes an argument that's going to be the index of the ticket. So this would be 0 through 10 or 0 through 9. But the keywords public or external, you can actually use external if you wanted to, means that only people outside of this contract can call it. So I'm going to put external here, and I'm going to say payable. Payable is a keyword that means that the method can actually be, the funds can actually be sent via this method into the contract. Okay, so that, remember, the contract is kind of like a wallet address, and people can send it money. But what we're saying is that to call this function, you're going to have to send some money in as well. All right, so the next thing we'll look at is all these require statements. Basically, these are catches that you can add into your function to verify that the user is providing the correct values, right? So the first thing you want to do is make sure that the index that's provided is less than total tickets. And we probably also want to make sure that the index is greater than or equal to 0. Make sure we don't go out of bounds. So I'm going to add that in. This is basically checking, make sure the user is buying a ticket from 0 to 9. So this is saying make sure that no one owns a ticket. So this is saying ticket of the index passed in owner is equal to the 0 address. So this is good. We want to make sure no one already owns a ticket. Now the next one is saying make sure that the user has sent in enough money to buy the ticket. So we're saying message.value. This is how you can actually get the money that was sent to this function when they're calling it. Remember, the payable keyword allows them to send funds. So we're going to make sure that they sent enough money, and it has to be greater than or equal to 1e to the 7 in this case. And then finally, if all that is set, what we're going to do is basically set that ticket to an owner. And I think that's all we really need to do. We don't even need to like reset the price, because I remember owner would be undefined if it's not owned. So again, this is a really like static contract. You can't add more tickets. You can't change the prices of tickets. You can't sell or resell tickets. So it's really basic, but I wanted to kind of just start with something simple so that you can kind of understand how this stuff works. So now that our Solidity contract is created, we do need to create a migrations here. So I'm going to go ahead and make a new file called tickets.js. And we can kind of copy the code exactly from this other tickets or this other file. I'm going to do that. This is basically just going to tell Truffle that, hey, I need to deploy this tickets contract when I try to run a migrate. And I'm going to go ahead and down here and say Truffle Migrate. So now this should know that I've already ran the migrations, the first migration here. And it should just see that I need to now run the tickets migration. So let's just go ahead and verify this is working before we start writing some tests. All right, so it's running through here. It's saying it's deploying tickets. We've got an address. It's probably taken Ethereum from this account. Let's drop down a little bit. We can go to contracts, see that the tickets contract has been deployed. And now if we look at the actual storage, we see that we have an array of 10 slots, and we have a bunch of tickets that are owned by no one, okay? So now we can actually start writing a test, right? Writing tests over your contracts are the easiest way to make sure your contract works perfectly. So in the test folder, I'm going to make a new one called tickets.js. You can name this tickets.test.js, whatever you want. But we are going to write out a kind of like a Mocha test using the built-in stuff with Truffle. So the first thing I'm going to do is bring in an assert library. So let's say require assert. And then I'm going to basically also import that contract. So I'm going to say const tickets is equal to artifacts. Artifacts is just like a global that you can use require tickets. Okay, so this will bring in the actual contract, and we can use that to actually test it. So the first thing you can do when you're writing these tests with Truffle is say contract, and very similar to Mocha or Jest where you have like a describe block, instead you're using this contract block, and I'm going to say tickets, and that is going to be passed in a list of accounts. All right, this is just how it works. Accounts is going to be all those accounts that were in Ganache. But anyway, what we're going to do is we're going to kind of declare a constant up here and say buyer is equal to accounts of 1. Because we're going to keep track of who bought the thing. And I'm going to go ahead and put a it statement. So this is how you do it. I'm going to say it should allow a user to buy a ticket. All right, so let's just go ahead and start writing out some tests for this. I'm going to move this screen down here a little bit. I might turn off Copilot. It's getting kind of annoying. Some of these autocomplete things aren't that useful. So the first thing I'm going to do is I want to make an instance. So I'm going to grab the instance of the contract. I'm going to say await tickets deployed. That's going to create a new instance of the contract that we can actually like modify and do things with. And we are basically going to call a function to make sure that the ticket we're trying to buy isn't owned by anyone. So I'm going to say original ticket is equal to instance. Yeah, actually I can do this. Let me make some more constants. Ticket ID is 0. All right, so we're saying when we deploy the contract, we're going to grab the first ticket using index 0. Remember, this is accessible because we added the public visibility keyword on this. If you go back to the contract, remember there is a public member called tickets. So that means anyone outside of the contract can actually access it and look at the information. So we're going to just call it like a function and pass in the index number to get the actual ticket that we're trying to buy. And now we can actually try to buy it. So I'm going to say await instance.buy ticket. Did I call it buy tickets or buy ticket? Let's see. I call it buy ticket, and we can pass in the index that we want. So I'll say ticket ID. Now, whenever you're doing this call, if it's a payable method, you actually need to say who it's from. So I'm going to say from buyer, and I'm also going to say value is 1e to the 17. Okay, so I believe that was the amount we needed to buy the actual plot. But actually what I could do instead is I could say original ticket.price. So basically this user is going to call the buy ticket function. They're going to say, I want to buy index 0, and I want to pass it the amount that is set for that ticket. So now after this is all ran, behind the scenes, the blockchain should change state, and we should see that the index 0 is actually owned by this buyer here. So what I'm going to do is I'm going to go ahead and copy this and say updated ticket. So now we have the old state and the new state, and we're going to check. So we're going to say assert equal, and we're going to say make sure that the owner of the updated ticket.owner is equal to the buyer. And I'm going to say the buyer should now own this ticket. All right, so I think that's enough to actually run something. Let's actually see if this works. So in your terminal, you can say truffle test, and you can pass it the actual path to the file. So I'm going to go ahead and pass it test/tickets. And that is going to spin up a isolated Ethereum network, and it's going to point this test contract and kind of do everything with that test contract locally. So if this all runs successfully, we should verify that the owner is set to the buyer after they bought the ticket, right? So everything looks like it works well, and you can kind of continue adding more tests. And a little thing I just noticed is that this actually does use the Ganache account. You notice here that this balance has been dropping every time I run the tests. So I think it is just resetting the state of the blockchain when you run the test, but it's still using the same accounts. So just keep that in mind. I think I told you that wrong earlier on. But yeah, that basically wraps up this part of the video series. Basically, we showed you how to write a Solidity contract where people can set up 10 tickets, others can buy the tickets and pay some money. And then we also showed you a quick way to write some tests to verify that these tickets actually do what we're supposed to do, where the owner is actually set correctly. And you can kind of further work on this and add more tests to verify that certain exceptions are thrown. For an example, you could try writing a test and try to pay less than the required amount, and this require statement should fail, and you can test that in your actual contract test down here. But that's all I want to show you for right now. I think the next part of the series, I want to use this method to basically build out a simple front-end user interface where I can connect to this contract, show these tickets, and actually have a button that you can use to buy these tickets. So stick around for the next part of this series if you're interested in learning more about writing Ethereum smart contracts and decentralized applications.